Hi everyone, I am Mr. Babukar Aw, your chemistry tutor, and today our lessons of discussion will be based on oxides and salts. Now our contents are types of oxides, and then we will deal with salts and also the types of salts, and then we will deal with preparations of salts, and then finally we have our assessment. Now we have many types of oxides. That is, namely, we have neutral oxides, we have basic oxides, we have acidic oxides, we also have amphoteric oxides, and also we have peroxides. Now we will deal with each of these oxides one after the other. Now the first one we have is acidic oxides. These acidic oxides, they are known as acid anhydrides. Now we said these are non-metallic oxides that react with water to form acid solutions. Now, if we have oxides like CO2, this carbon here is a non-metal. With oxygen, it will form non-metallic what? Oxides. Now, when this type of oxides reacts with water, that is H2O, in a reversible reaction, this can form H2CO3, and this is going to be what? Aqueous. And this compound now is what? An acid. So you see, we have the non-metallic oxide with water, and then it forms an acid. That's why we said these acidic oxides are non-metallic oxides that react with water to form acid solutions. And then the examples are CO2, we also have NO2, we also have SO2, etc. and etc. But none of the metallic oxides can form acid oxides. So these acid oxides, we just have what? The non-metallic oxides. And also not all non-metallic oxides also are able to form these acid oxides. Again, we move to the second one, which is basic oxides. Now the basic oxides are also known as base and hydrides. So these are metallic oxides that react with water to form basic solutions. Like we have Na2O, and this Na2 is known as sodium oxide. Now when this sodium oxide reacts with water, it has the tendency to form sodium hydroxide, and this sodium oxide now is going to be what? Aqueous. And here we have what? A base. Now you see we have a metallic oxide, because sodium is a metal. With oxygen it will form what? A metallic oxide. Now the metallic oxide dissolved in water, it will form sodium hydroxide, which is what? A base. So whenever you react basic oxide with water, they will form a basic solution. And the examples are Na2O, that is sodium oxide, magnesium oxide, calcium oxide, etc. and etc. Of course, we also have other examples of basic oxides. Now, the third type of oxides are called amphoteric oxides. Now, this one here we have from the word ampho. Ampho. And then this ampho now means what? Dual, which means two. So here, these oxides which shows, or these are oxides which shows both basic and acidic what? Properties. Both acidic and what? Basic what? Properties, which means they are dual. So they have a tendency to react with what? With acid. They also have a tendency to react with what? With base, which means these oxides can play the role of acids and also can play the role of what? Base. Now let's take one of the oxides there, which is Al2O3, aluminum oxide, which is an example of amphoteric oxide. So this aluminum oxide with an acid. See now, in this case, the aluminum oxide now is playing the role of what? The base, because it is reacting with what? With the acid. So when they react, it will form AlCl3 plus. AlCl3 plus, we have our water. So here, Aluminium oxide reacted with the acid to form aluminium chloride, which is the salt, and also molecules of water. That is Al2O3 reacting with what? With the base. With a base. So here the amphoteric oxide is reacting with what? With sodium hydroxide, and now it will form NaAl4. It will form sodium tetrahydroxyaluminate 3. That is sodium tetrahydroxyaluminate 3. So here you see this oxide, which is ampho, is able to react with what? Sodium hydroxide to form this compound, and also the same oxide, which is ampho, is able to react with what? Acids to form aluminum chloride and also water molecules. Now the fourth one we have is called neutral oxides. Now we said these neutral oxides, they are non-metallic oxides that are neither acidic nor basic, and the examples are CO, NO, N2O, and also water molecule. Now I said CO, which is carbon monoxide, is known as the secret what? The secret killer, because this gas is colorless. The gas is also what? Odorless, and then it can easily cause what? Suffocation. And when you are inhaling CO, you will not know, because there is no odor and also there is no color associated with the what? With the gas. Now this gas is what? Is neutral. And then NO also is neutral, N2O is neutral, water, which is also a very what? Common molecule, is also neutral. So these are the types of neutral oxides we have. Or peroxides are oxides that react with dilute acids to form hydrogen peroxides. The examples are Na2O2, K2O2, etc. and etc. For example, if you have Na2O2, now when you react this peroxide, which is sodium peroxide, with dilute acids like HCl, we assume the acid here is dilute. Now it has the tendency to form NaCl, and again to form H2O2. So you see now, you have your sodium peroxide, you react it with what? With dilute acid, and now it forms what? Sodium chloride and also the hydrogen peroxide. The same thing happens when you use what? Potassium peroxide. That is the other example there with HCl, which is going to be what? Dilute. It will form KCl, and also hydrogen peroxide also is produced. I think hydrogen peroxide also is produced. So these are the 5 types of oxides we have. That is acidic, basic, neutral, amphoteric, and also peroxides. Now we move to salts. Now we said salts, or a salt is a substance formed when the hydrogen ion or the hydrogen ions of an acid is replaced by a metal or metallic radical. Example, we have sodium chloride, calcium chloride, and also potassium hydrogen triiosocarbonate 4. So all these things are examples of salt. Now the first example there, which is sodium chloride, is the common salt or the table salt we normally have at homes. Now the metal could be any element from the periodic table that is a metal. You can use anyone and then it will be able to form what? But only if that metal is above hydrogen in the what? In the series. Because for a salt to form, a metal or that metal that is reacting with the acid should be able to what? Displace the hydrogen in its aqueous solution. And then the metallic radicals, we have ammonium ions and also the hydronium ions. So these are the what? Metallic radicals. But this is the most common metallic radical that can easily react with acids to form salts. Now, for example, we have HCl as the acid, and again we have what? Zinc metal. Now, because zinc is above hydrogen in the series, so zinc can easily what? Displace hydrogen in this aqueous solution, and then it will form zinc chloride, and also hydrogen gas is what? Evolve. Now, in the metallic radicals, we can still have the same acid reacting with what? A compound of what? Ammonium. Like this. Now, the metallic radical now here is able to what? Displace hydrogen in this aqueous solution, and now we'll have something like ammonium chloride, and also hydrogen gas is evolved. In this case, we are using a metal, and in this case, we are using a metallic radical. So we can define salts using metal or using what? A metallic radical. But only if the metal and the metallic radical are able to what? Displace hydrogen ion in its aqueous solution. Now we have types of salts. Types of salts. Now the first one we have is called normal salts. Now we said normal salts. These are salts formed when all the replaceable hydrogen ions of an acid are completely replaced by a metal or metallic radical. By a metal or metallic what? Radical. And the first one we have is called what? The normal salt. If you have acid like H2SO4, when we are discussing about acids, we said we have what is called basicity. That is basicity of acids. And then we said is the what? Number of replaceable hydrogen ion in 1 mole of an acid. If you have HCl, H2SO4 and H3PO4, just to name a few, if you have this acid has what? Single proton. So the basicity here is going to be what? 1. We have 2 protons here, the basicity is going to be 2. We have 3 protons here, and basicity is going to be what? 3. So a normal salt is formed when the basicity of that acid is totally what? Replaced in its aqueous solution. In this case, we have what? The basicity of what? 2. So if we have a metal like what? Iron, and this iron is able to replace both these 2 atoms of hydrogen, and therefore it will successfully form what? A normal salt. In this case, we can have iron sulfate plus what? Hydrogen gas. So in this case, a normal salt is what? Is formed. We can also have something like we have sodium reacting with what? With an acid. So this sodium now is able to replace the hydrogen. We'll have NaCl plus what? Hydrogen gas. So now this salt also is what? Is called a normal salt, because this sodium is able to replace what? All the hydrogen ion in this aqueous what? In this aqueous acid. So always normal salts are formed when the replaceable hydrogen ions in the acid are completely replaced by a metal or metallic radicals. And then when you have your normal salt, most of them they have no effect on litmus paper. Now the second type of salt we have is acid salts. So these acid salts, they are salts that form when the replaceable hydrogen ions of an acid are partially replaced by a metal or metallic what? Radical. For example, we have this kind of acid, that is H2SO4. Now, when you react this H2SO4 with any other metal, and that metal is only able to replace part of these hydrogen ions, then therefore an acid salt will be formed. Like maybe you have 2 atoms of what? Hydrogen. So if you react this with what? With a metal, that metal is able to what? Replace one of these. You can still have what? FeHSO what? SO4, which means now this Fe replace what? One of the hydrogen ion in this what? In this acid, and then you'll have something like what? Something like this to complete the salt. Now, to have a proper example, here we can say we can have H2SO4 plus, we can react this with what? With, let me use potassium. Yes, you see I'm using diabasic acids, because only diabasic acids and what? Tribasic acids can form acid salt. Monobasic acids cannot form what? Acid salts, because they only have a single replaceable hydrogen ion. So in this case, we will have KH. You see now, this K will only replace one of the what? hydrogen atoms in this acid solution. The other one will remain, and then you'll have your what? Your SO4 plus your what? Your hydrogen gas. So in this case, we said we have what? An example of what? Of an acid salt. Which is the first example on the board, which is KHCO3, and this one is KHSO4. Because another example also is NaHSO4, that is sodium hydrogen tetraoxosulfate 6. The third type of salt we have is called the basic salt. Basic salt. Now, these are salts formed when the hydroxide or the oxide ions of a base are partially replaced by an ion, and then therefore these basic salts are mixed with salt oxides. And the example we have is calcium chloride hydroxide and also bismuth 3 chloride oxides. And then we have now in the basic salts, we have elements with oxidation numbers of +1. We also have elements with oxidation number of +2 and also +3 and what? And the like. So any element that is having oxidation number of +1 cannot form basic what? Salt. So these elements cannot form what? Basic salts. Like sodium, potassium, they cannot form what? Basic salts. Because a basic salt, the central atom must be able to react with what? With the oxide or the hydroxide, and also at the other end, it will be able to react with what? With the anion. For example, we have calcium chloride hydroxide. So you see, calcium, if you draw the bond, you will have something like this, and then the valency of calcium is 2. So calcium will be able to react with this chlorine on this side using this electron, and then it will be able to react with what? With this hydroxide using this electron. But if you are using something like a group 1 element like sodium, the valency is what? Just 1. So when it reacts this side with chlorine, it cannot react with the what? With the hydroxide or with the what? With the oxygen. So therefore, for basic salt to be formed, the central atom, which is this calcium now, should be what? Should have oxidation state of +2 or +3. We also have double salts. Double salts. Now, these double salts, they have their own general formula, and the general formula is X2SO4. You also have Y2SO4 in bracket 3, and then you have 24 molecules of water. So this is the general formula of double salts. And this Y can be any element with an oxidation number of +1, and this Y can be any element with an oxidation state of what? +3, and they are known as alums. And these alums are used in the purification of water, and then they normally what? They normally coagulate the impurities contained in the water so that you can easily filter it. Now, double salts are salts formed from the equimolar aqueous solution or equimolar aqueous mixtures of 2 salts. Example, you have the KlSO4, and then you have 12 molecules of water, and this is called potash alum, and also another one is the chrom alum. So you see now, that compound in the board is just what? Simplified, because the actual number of molecules is what? 24, and then you can reduce this, and after you can have here something like 12. But then the most important thing here to note is X can be any element with an oxidation state of what? +1, and then Y can be an element from what? Or with an oxidation state of +3. And then we have 2 examples on the board that are the chrom alum and also the potash alum. Now, number 5, we also have complex salts. Complex salts. Now, these complex salts, they must contain a radical or a neutral molecule that will play the role of a ligand. For example, we have K3FeCN6. This compound now is called complex salt because of this ion. This potassium hexacyanophosphate 3, and this compound is an example of a complex salt because it contains what? Ion. And ion is what? A transition metal. So one of the properties of transition metal is they form complex ions. So when the ion is contained in the compound also becomes what? Complex. Another example we can have is tetraamine copper 2 tetraoxosulfate 6. In this case, we have what? A ligand. Now this ligand here is a neutral molecule that can directly donate 2 lone pairs of electrons. That is, if you draw this bond now, you know that ammonia is having what? A lone pair what? Of electrons. This copper donates its lone pair electrons to this SO4, so that they will bond. Now those lone pair or those 2 lost electrons will be replaced by what? By the ligand. That is in the form of what? Dative bond. So this one also is an example of what? A complex salt, and it is called tetraamine copper 2 tetraoxosulfate 6. Now the last type of salt we have is called hydrated salts. Now I've said these are compounds that contain water of crystallization. So any salt that contains what? Water of crystallization. The water of crystallization can start from 1 to any number. So those kind of salts are called what? Hydrated what? Salt. Some of these hydrated salt, for example, they have different color with the what? With the anhydrous form. If you have this, which is copper 2 tetraoxosulfate 6, when it is in the form of anhydrous, the color becomes what? White. But when it is hydrated, because it has the ability to hold what? 5 molecules of what? Of water. Now the color becomes what? Blue. Hydrated salts, the word hydrated there doesn't mean they will go into what? Solution, but they will just absorb what? Part of water of crystallization. We can, or if the element, if the compound is having a transitional metal, it can change the color, that is the initial color, from another color to show the hydrated nature of the what? Of the salts. And then finally we have the preparations of salts. Now salts can be prepared using different methods based on the type of salt you want. Now the first method we have here is called direct combination. Direct combination. Direct combination here, you will react what? The constituent what? Elements. Here we have chlorine, gas, and also what? Zinc, which is solid. Direct combination here, we will form zinc chloride, which is also going to be what? Going to be solid. Now again, another method which can be used to prepare salts is called neutralization. And we know that this type is very, very common. That is, we use an acid and also what? A base. So when you react an acid and base, we said salt and water is formed. So the salt which is going to be formed here is going to be NaCl and also water molecules. So this is called neutralization reaction. Now the other type that we can use to prepare salt is action of acids on metals. That is action of acids on metals. If you have your acid and then you add these kind of metals on the acid, so effervescence will occur, hydrogen gases evolve. So when effervescence stops in this reaction, you know that the salt is formed. That is, the reaction has completed. Now action of acid on the metal, we will have zinc chloride plus hydrogen gas. In this reaction, we use this hydrogen gas to determine whether the reaction is completed or not. Number 4, we have by the action of acids on trioxocarbonate salts. In this method, you only have one type of salt, but you need another type of salt. You can use a salt to form another salt. That is action of acids on what? Trioxocarbonate salts. If you have HCl acid with what? Any trioxocarbonate, like sodium trioxocarbonate 4. See, it will form NaCl. It will again form H2O, and finally it will liberate what? CO2. So in this case, the salt is what? NaCl. We have a salt which is called sodium carbonate, but we don't need it. That's why we are reacting with the acid to form this kind of salt, which is going to be our what? Our main product in this reaction. And then finally, we can prepare salt by the action of acids on triazosulfide 4 salts. That is number 5. We can have the action of acids on what? Something like sodium triazosulfide 4. So the same thing. We have a salt, but we need another type of salt. When you react it with this acid, it will form NaCl, because the sodium will take off the what? Anion from the acid to form sodium chloride. And again, water is formed, and finally, a gas is evolved from this radical, which is going to be SO2. But our main product in this reaction is going to be the sodium chloride. That is the main what? That is the main product. So these are the methods that we use to prepare salts. And then finally, we have the assessment. Now, you can do this at home, and then the questions reads, number 1A, what is basicity of an acid? Here you are asked to define briefly what is basicity of an acid. And then B, determine the basicity of the following acids. That's Roman figure 1, we have ethanoic acid. And then Roman figure 2, we have the tetraoxophosphate acid. And also Roman figure 3, we have tetraoxosulfate 6 acid. Number 2, tetraoxosulfate 6 acids and sodium hydroxide reacted to produce salt and water. Because we know the first one is the acid, and the second compound there, sodium hydroxide, is the base. Now we are asked to write a balanced chemical equation for the formation of Roman figure 1, normal salt, and then Roman figure 2, acid salt. So this reaction can give you both normal salt and also what? Acid salt. So write a balanced equation to show this process. Now with this, we come to the end of the lesson. So stay tuned to our subsequent videos.